Newhall Watermill is situated in Sutton Coalfield, at the southern end of Newhall Valley, through which runs the stream which is now called Plantsbrook, but which was formerly known as Eastbrook. The mill pond was originally fed by this brook, but a continuous water supply was cut off in the 1960s, and the pond is now topped up using a holding tank. The water from the pond enters a wooden pen trough before falling on the water wheel. The height of the sluice gate determines the amount of water that flows over the wheel and hence its speed. It is regulated by an interesting chain mechanism which is controlled from inside the mill. Here we can see where the axle enters the building. It's attached to a very simple but effective lever, which, when turned, raises or lowers the sluice gate. Any excess water in the pond falls over a weir and returns through a tunnel to Plantsbrook. Looking over the railings in front of the water wheel housing, you can see the water coming under the sluice gate and falling on the wheel. As we enter the mill, we are greeted by a confusing array of rotating wheels and belts. Our first step in understanding how everything works lies in that opening on the left, where you can just see a moving gear wheel. This is where the shaft of the water wheel enters the building and is attached to the huge gear wheel called the pit wheel. The pit wheel engages with a smaller gear called a wallower, which is attached to the main axle in the building. Here you can see it rotating and turning the main axle. In order to rotate the horizontal millstones, the power must be transferred to a vertical shaft. This is done using two beveled gears at right angles. The one in use can just be seen at the back. There above is the vertical shaft that turns the millstones. It's got a piece of straw tied to it. That hand wheel is important and will be dealt with later. But first we will turn our attention to the wooden chute down which the flour descends from the floor above. Behind it you can see a black rotating shaft which turns the millstone. You can see both of these on this diagram. The chute is in brown and the rotating shaft supporting the runner stone is in red. That rotating shaft must be moved up or down in order to maintain the correct gap between the millstones. This is done using a mechanism called the tentering gear. The rigid support of the mechanism is situated below the beveled gear wheel, which is called the stone nut. The stone nut is on the rotating shaft that turns the millstone. The tentering lever below the support carries the whole weight of the millstone and the shaft. Rotating the hand wheel clockwise raises the lever and the shaft and so increases the gap between the millstones. As the millstones wear, the wheel must be turned the other way in order to maintain the right gap. The tentering gear that we can see is the one not being used. If the shaft is raised a lot, the cogs will disengage. This mechanism, similar to a car jack, allows the cog to be moved up or down the shaft as required to maintain proper contact. In this picture you can see the link joining the lever to the wheel mechanism. We have looked at the ground floor. Now we must go to the floor above and look at the millstones. The Hurst posts support the fixed bedstone. The upper one is called the runner stone and rests on a piece of iron called a rind. This in turn is attached to the mace, which is attached to the rotating shaft. They are all enclosed in a wooden box called a tun. We shall return to the milling process later. First we will go outside and see how the mill pond is kept topped up. The water that comes from the water wheel enters the tail race and travels under the buildings to the holding tank. When the holding tank reaches a certain level, a powerful electric pump is activated automatically. This quickly empties the holding tank and returns the water to the mill pond. The water wheel is not the only source of power. When the water supply became unreliable, the miller, Ben Davis, installed a diesel engine in 1949. The diesel engine runs two machines at the back of the building, a combined milling machine and the mechanism for the sack hoist. Let's follow the belts to the milling machine. We have seen how the diesel engine drives the milling machine, and now we look at the sack hoist. The mechanism is situated at the top of the building just below the garner floor. The grain arrives in heavy bags on the ground floor and must be lifted to the top floor where it would be stored. It will be hoisted up through a series of trapdoors. The miller, working on his own, would count the number of clonks as the traps closed in order to tell when the load had reached the top. The hoist is controlled by a rope pull. The journey would start on the ground floor. Up there is the first trapdoor. The rope pull goes right up to the top floor. This is the first trapdoor from above, and there is the rope pull beside it. Pulling the rope activates the winding mechanism. Here are the levers that operate the clutch. The drive from the diesel engine rotates continuously, but only activates the drum holding the chain when the levers are pulled upwards. In the past, as many as 50 sacks of grain were stored on this garner floor. From here the grain is poured into a chute which feeds the hand-operated winnowing machine. On the way it passes through an aspirator where the dust is blown away. This machine is driven by the water wheel.
All the way down.
The winnowing machine has a series of meshes through which the grain is forced. This results in unwanted rubbish, like odd stalks, being removed. When processed, the clean grain can be ground into flour. Before windmills and watermills, the grinding of corn into flour was done by hand using a rotary quern. In many parts of the world, such methods are still used.
Normally what they do when they're doing it, they would keep it just topped up all the time.
Yes.
Obviously.
I think of the leader.
It's now time to look at the grinding process. The grain enters through the eye, is crushed between the millstones, and emerges at the edge as meal, which collects in the tun and drops down a wooden chute to the floor below. The best millstones come from France and are made up of blocks of chert which have been shaped and set in plaster. The surface of the millstone is divided into furrows and lands. This picture of an old millstone shows the blocks of chert. On it you can see some furrows and the fine grooves on the lands called stitching. The number and design of the furrows is important. They are designed to move the grain from the eye to the edge of the stone and at the same time force them up onto the lands where they are crushed and ground into meal. You can see the overall pattern in this diagram of the bedstone. The runner stone has exactly the same pattern, but when turned upside down will have the furrows in the opposite direction, so that when it rotates, the action is that of many scissors. Having looked at the millstone, we now turn our attention to the wooden structure above, which is called the horse. We have already seen the clean grain being tipped into the hopper. From there it drops into the shoe and is directed into the eye of the millstone. To keep the grain moving, the shoe vibrates. This is done by means of a rotating piece of metal called a damsel. The tension on the shoe is maintained by means of a piece of string attached to the miller's willow, which acts as a spring. The rate at which the grain is fed into the eye is controlled by the angle of the shoe. From the tun, the meal falls through the wooden chute to the floor below, where the miller can examine the flour and adjust the gap between the millstones if necessary. Millstones need regular maintenance. To do this, the tun must be removed and the runner stone lifted and turned over. Not an easy task when the stone weighs some 3/4 of a ton. In the past this was done using a block and tackle attached to a roof beam, but this was deemed unsafe for today and a special stone lift is now used. To the left of the picture you can see a display of photographs showing the work being done. At top left, the stone is being examined for any high spots. These must be hammered away. The process has to be done several times. The furrows then need to be deepened. Finally, the lands must be stitched, that is, fine lines chipped into the surface. This is done using a mill bill, a double-edged piece of toughened steel set in a wooden handle called a thrift. In the bottom left-hand corner, you can see a millstone dressing machine being used. Here are all the tools on display. The miller had to be able to do most of the maintenance of the mill by himself. He could not afford to wait for somebody to come out and fix his problem. Here we see a reproduction of a typical miller's workshop. In the centre you can see the wooden teeth of a gear wheel being replaced. On the other side is a mixture of tools needed for the maintenance of the house and grounds. In the centre you can see some large pliers. These were used to stretch the leather in shoes in order to accommodate bunions. There is much more that could be said about the mill and its open days, but that will have to wait for another occasion.